Welcome to today's lesson. So today we're going to look at Science GCE 2023. Okay, B6. So figure B 6.1 shows a ray of light traveling from a glass to air at an angle. The refractive index of glass is 1.52. Okay, so they're saying define critical angle. Okay, so let's define critical angle. So we can say this is the angle of incidence in the denser medium at which the angle of refraction becomes 90 degrees. So this is how you define the refractive index. So this is the angle of incidence in a denser medium at which the angle of refraction in a less denser medium becomes 90. Okay. Calculate the critical angle in the figure above. So we're here. How do we calculate the critical angle? We say refractive index is equal to 1 over sine of critical angle. Do we have the refractive index? Yes, we have 1.52. Okay, equals 1 over sine of critical angle. Okay, let's do this. So that 1 times 1 is going to be 1, and then this one times that one, 52 sine of critical angle. So I've multiplied this one by that, so I can divide 1.52 and also 1.52, so that this one and that one cancels, so remain with this. And then when we divide that, you're going to have you're going to have 0.657894. Okay, so now from there we can divide sine. Okay, we can divide sine throughout, so we can divide sine. Even here we divide sine, so that sine and sine cancels one another, so we're going to have this. Okay, so this can also be written as sine of inverse 0.657894. Okay, so when you press this on your calculator, sine inverse, so you're going to say shift and then sine on your calculator, and then you write 0.657894. so the answer that is going to be there is going to be 41.14 degrees. Okay, so we have actually calculated for critical angle. Okay, so if you followed the steps, I'm sure you've arrived at an approximation of this angle. Okay, So let's go to C. States two conditions. States two conditions for total internal reflection to occur. Okay, the first condition is that light must travel from a denser medium to a less denser medium. As simple as that. So light is traveling maybe from a glass block to air. So it must travel from a denser medium to a less denser medium for us to have the total internal reflection. Okay. The other point is that the angle of incidence must be greater than the critical angle. So the angle of incidence must be greater than the critical angle. Okay. Let's move on. They're saying give one application or use for total internal reflection. So okay, one of the application is in optical fibers. Okay, what happens there? Used to transmit light segments with minimal loss. Okay, so this is all that we had today. Thank you for watching, and remember to like, comment, and also subscribe.